What if the greatest discovery in human history isn't waiting for us in the stars, but is currently drowning in the dark, trapped beneath miles of alien ice? Forget the dusty, dead plains of Mars. The real hunt for extraterrestrial life has violently shifted to the frozen shores of Jupiter's moon, Europa. We are talking about a hidden global ocean that forces us to rethink everything we know about biology and survival. I'm your host, and here on Astro Trivia, we are cracking the ice on the solar system's most profound mystery. Let's dive in. To the naked eye, Europa doesn't exactly look like a thriving oasis. Discovered by Galileo Galilei back in 1610, it sits roughly 480 million miles away from the warm embrace of our sun. Slightly smaller than our own moon, Europa looks like a massive cracked eggshell suspended in the brutal void of the outer solar system. Its surface is a blindingly bright, practically featureless wasteland of white ice, brutally scarred by reddish-brown fractures stretching for thousands of miles. For decades, it was just another frozen rock in astronomy textbooks. Beautiful to look at, sure, but biologically, it was assumed completely dead. Then, the late 1990s fundamentally changed the game. NASA's Galileo spacecraft swung through the Jovian system and detected something completely unexpected: massive rhythmic disruptions in Jupiter's immense magnetic field, right around Europa's orbit. To a planetary scientist, that specific kind of magnetic signature points to one very undeniable phenomenon: a colossal, rotating body of electrically conductive fluid moving beneath the crust. Suddenly, the frozen rock hypothesis was dead in the water. Europa isn't solid ice. Beneath a hardened outer shell, estimated to be anywhere from 6 to 20 miles thick, lies a global, pitch-black ocean. And when we say ocean, we aren't talking about a few isolated subterranean puddles. We are talking about a sprawling, abyssal expanse of liquid water that could be up to 100 miles deep. Let that staggering scale sink in for a second. This distant moon is hiding a subsurface sea containing at least twice the volume of liquid water as every ocean, river, and rain cloud on Earth combined. Why is the scientific community obsessing over this? Because in the ruthless, unforgiving mathematics of astrobiology, liquid water is the singular, non-negotiable currency of life. It is the ultimate universal solvent, the necessary medium where complex chemistry can actually mingle, bond, mutate, and eventually evolve into biology. Its mere presence doesn't guarantee that alien organisms are swimming around down there, of course, but it forcefully kicks the door to possibility wide open. For over 2 decades, that open door was all we had. We knew the water was there, but we were essentially locked outside, pressing our faces against a frosted window, completely blind to what might be happening in the dark. We couldn't tell if the chemistry in that alien water was entirely inert or primed for life. To move from a wild hypothesis to actual exploration, we needed evidence that the true ingredients for life were actually in the mix. Let's tackle the massive, freezing elephant in the room. How in the universe does an ocean remain in a liquid state nearly 500 million miles away from the warm, life-giving glow of our sun? If you were to stand on Europa's blinding white surface, you'd be subjected to a bone-shattering -260 degrees Fahrenheit. By all conventional logic of planetary science, this entire moon should be frozen solid, all the way down to its rocky core. But it isn't. And the reason why is a masterclass in cosmic physics. Europa's heat doesn't come from a star, it comes from a monster. Europa is caught in a relentless, inescapable gravitational tug-of-war. On one side, you have Jupiter, a gas giant so impossibly massive it could swallow over 1,000 Earths. On the other side, you have Europa's sibling moons, primarily the volcanic hellscape of Io and the mammoth Ganymede. As Europa orbits Jupiter, its path isn't a perfect circle, It's slightly elliptical. This means the moon is constantly being pulled closer to Jupiter, then flung slightly further away, over and over again in a rhythmic orbital dance. This eccentric orbit forces Europa to endure a brutal physical workout called tidal heating. Imagine taking a thick, rigid paperclip and rapidly bending it back and forth in your hands. What happens to the metal in the middle? It gets incredibly hot. That is exactly what Jupiter's gravity is doing to Europa's interior, but on a mind-boggling planetary scale. The sheer friction generated by millions of cubic miles of rock and ice constantly stretching and compressing creates a staggering amount of internal heat. And this isn't just about keeping the water from freezing into a solid block. This gravitational engine is likely driving something far more profound at the very bottom of that alien sea: hydrothermal vents. In the pitch-black, crushing depths of our own oceans on Earth, where sunlight has never reached, we have found towering volcanic chimneys spewing out mineral-rich, superheated water. These deep-sea ecosystems don't rely on the sun. They thrive entirely on chemical energy. In fact, many evolutionary biologists believe this exact, dark, churning environment is where all life on our planet originally began. Jupiter is essentially providing the ultimate perpetual power plant to keep Europa's deep-sea chemical kitchen open for business, and it has been running without interruption for billions of years. So we have a massive, ancient ocean, and we have a constant, reliable energy source to keep it warm. But for a long time, that was where the trail went cold. It is incredibly frustrating to know a global ocean is sitting right there in our cosmic backyard, but being completely unable to peer through the thick, frosty glass of its outer shell. We needed to know if the actual ingredients for biology were swimming around in that dark water, or if it was just an empty, sterile abyss. Enter the James Webb Space Telescope. While everyone was mesmerized by JWST's stunning images of distant galaxies and nebulas, it quietly turned its hypersensitive near-infrared spectrograph toward our own solar system. It didn't need to land on the ice or drill through the crust. Sitting over 600 miles away, Webb stared at Europa and achieved something almost unreasonably precise. It read the chemical fingerprints written directly onto the moon's surface. In late 2023, the scientific community was hit with a bombshell. Webb detected highly concentrated deposits of carbon dioxide on Europa. Now, finding CO2 in space isn't exactly front-page news by itself. The critical part is where Webb found it and what that specific location implies. The carbon wasn't thinly and randomly scattered across the entire moon, which is what you would expect if it had been delivered by random meteorite strikes over the millennia. Instead, it was highly localized. It was heavily concentrated in a specific region known as Terra Regio. This is a geologically young, chaotic terrain where the ice shell has been heavily fractured, shattered, and refrozen. It is exactly the kind of disrupted landscape where deep, pressurized ocean water is theorized to well up and breach the surface. This tells us something revolutionary. The carbon didn't come from above, it came from below. The structural backbone of every single known form of life, carbon, is actively dissolved in Europa's hidden ocean. And it gets even better. When researchers dug deeper into Webb's data, they realized the carbon dioxide wasn't sitting there alone. It was mingled with specific dissolved salts, including sodium chloride, literally table salt, and magnesium sulfate. These are the exact same mineral profiles you would find if you scooped a glass of water out of the Pacific Ocean. Webb essentially caught Europa's ocean actively communicating with its surface. It proved that this hidden sea isn't just pure, inert, distilled water. It is a complex, chemically rich, and dynamic soup. Astrobiologists look for 4 pillars to determine if a world is habitable: liquid water, an energy source, organic chemistry, and enough time for complexity to develop. We already knew Europa had the water, the energy, and the billions of years of time. Thanks to the James Webb Space Telescope, we now have undeniable proof of the chemistry. The final puzzle piece is officially on the board.
Now, before you pack your bags and book a one-way ticket to the Jovian system, we need to talk about the brutal, terrifying reality of Europa's neighborhood. Europa possesses what engineers affectionately call a survival calculus that is entirely unforgiving. The biggest threat isn't the freezing temperature or the lack of a breathable atmosphere, it's Jupiter itself. Jupiter possesses a magnetic field so incomprehensibly powerful that it acts like a colossal particle accelerator, whipping electrons and ions around at near light speeds. This creates an intense, lethal radiation belt that continuously blasts Europa's surface. We are talking about an unrelenting onslaught of roughly 540 rems of radiation every single day. To put that in perspective, if you were to stand on the surface of Europa in a standard modern spacesuit, you would receive a completely lethal dose of radiation in just a few short hours. It is an immediate, inescapable death zone. This radiation is so severe that it rapidly destroys any complex organic molecules resting on the surface. Even if ocean water containing the biological building blocks of life were to erupt onto the ice, Jupiter's radiation would chemically dismantle the evidence within a matter of decades, making it incredibly difficult for us to detect biology from afar. But here is where Europa's paradox becomes truly mind-bending. The exact same radiation that makes the surface a lethal wasteland might actually be the key to supporting life down in the dark. When these high-energy particles smash into the frozen surface, they literally tear the water molecules apart. This violent atomic process creates new compounds, specifically hydrogen peroxide and, crucially, molecular oxygen. Planetary geologists believe that Europa's constantly shifting, churning ice shell acts as a slow geological conveyor belt. Over millions of years, this radiation-produced oxygen is slowly dragged downward through the miles of fractured ice, eventually melting and dissolving into the pitch-black ocean below. So, the very same force that sterilizes the surface is actively pumping oxygen into the deep sea, providing a massive chemical fuel source for any potential biology. The thing trying to kill us might literally be feeding the aliens. This creates a massive paradigm shift for the future of space exploration. If humans ever establish a physical presence on Europa, the surface is entirely off-limits. The question isn't how we build a habitat on the ice. The question is, how fast can we melt our way into it? Any long-term human outpost would have to be built deep inside the ice shell itself. You would need to descend several dozen feet just to let the dense ice act as a natural radiation shield. On Europa, the ice isn't just an obstacle blocking our view, it is the ultimate architectural foundation for survival.
So how do we actually prove what is hiding beneath that deadly irradiated ice? We send the most sophisticated piece of machinery ever built for the outer solar system. In October of 2024, NASA officially launched the Europa Clipper mission. It is currently tearing through the absolute void of space, locked onto a trajectory that will bring it to the Jupiter system by the year 2030. But Clipper is facing an incredible engineering hurdle. It physically cannot orbit Europa. If it tried to establish a permanent orbit around the Moon, Jupiter's extreme radiation belts would fry Clipper's multi-billion-dollar electronics within a matter of weeks, even with its critical computing core encased in a heavy-duty, impenetrable titanium vault. Instead, the mission relies on a brilliant hit-and-run strategy. Over several years, Clipper will execute roughly 50 daring, high-speed flybys. It will swoop in, skimming as close as 16 miles above the deadly surface to gather a massive cache of data, and then immediately retreat to a safer distance to transmit the information back to Earth before the radiation damage becomes fatal. And its payload is perfectly designed to decode the ocean without ever needing to drill a single hole. One of its most exciting instruments is called SUDA, the Surface Dust Analyzer. Europa is constantly being pelted by tiny micrometeorites, kicking up microscopic grains of ice into the vacuum of space. SUDA is essentially a high-tech catcher's mitt. It will fly through these invisible clouds of debris, catching and chemically analyzing these ice grains on the fly. If even one of those microscopic fragments contains the distinct organic signature of life expelled from the ocean below, it will change planetary science forever. Clipper is also carrying Reason, a massive ice-penetrating radar. This instrument will ping the moon's shell, looking for bright reflections that indicate shallow, hidden lakes of liquid water trapped within the ice itself. If these pockets exist, it means we wouldn't even need to drill all the way to the ocean floor to find biology. The alien water might be sitting just a few miles beneath our boots.
The stakes of this mission are almost impossible to overstate. We are no longer just looking for a cool astronomical anomaly or a pretty picture for a textbook. We are testing the very nature of existence. If the Europa Clipper finds the undeniable chemical building blocks of biology in those frozen waters, it proves that the spark of life is not a miraculous one-off fluke restricted solely to Earth. It means the universe is practically hardwired to create life wherever the right ingredients meet. We are on the absolute verge of finding out if we are truly alone. Thank you so much for joining me on this incredible journey. If you want to stay on the bleeding edge of cosmic discovery and solar system exploration, make sure to hit that like button, share this video with a fellow space nerd, and subscribe to Astro Trivia. We have an entire universe to explore, and I'll see you in the next one.